In this lesson, we are going to learn how do we find the volume. So let's have a look at the case number 1. So for some of the cases, if we revolve the curve about the x-axis, our volume will be pi r squared dx, and r is the function of x. The volume for revolving about y-axis will be pi r squared dy. So generally speaking, for both of the formulas, when we revolve about x or y axis, there shouldn't be a hole in the problem. So in this case, we are going to call the disk method. Let's have a look. Example 1, y equals x squared, y equals 0, x equals 2 about the x-axis. So generally speaking, we draw a dashed line here. This is our revolving axis. Y equals x squared, y equals 0, and x equals 2. Y equals 0 is this region. So when we revolve this part about the x-axis, there will be no hole for this solid. In this case, we draw a line perpendicular to the x-axis. So this is our r of x. So volume, first we decide we are going to integrate along the x direction, and x is from 0 to 2. The inside should be r squared. Don't forget pi here. R in this case will be a function of x, which is x squared. And then you can integrate this pi r squared. So it's pi 0 to 2 x to the 4th dx. That's the volume. Let's look at this one. So y equals x squared, x equals 0, x equals 0, which is this line, and y equals 4. So this is the region. We are revolving about the y-axis. That's our revolving axis. So first, we draw a line here, perpendicular to revolving axis. This will be our r. So in this case, we are going to integrate the volume. Will be integration about dy here. Y will be from 0 to 4. So now we have to find the equation, okay, for r here. So r is this point minus 0. So this point is y equals x squared. Keep in mind, this inside function has to be a function of y. So x equals square root of y. That's our r. Now we plug everything in. So if we look at this problem, both x and y axis, there will be no hole when we revolve about these two axes. The Washer's method. When we revolve about any line, sometimes there is a hole. In this case, inside function will be big R squared minus lowercase r squared dx. So this will be a function of x. Or dy will be a function of y. If we revolve about y equals, we'll use dx. X equals, we use dy. Let's have a look at the example. Find the volume if we rotate y equals x squared. Let's draw a picture. This is the region. We revolve this one, part A, about line x equals 2. So in this case, if you look at this problem for part A, there's no hole in the problem. So we only have one r in the problem. This is our rotating axis. We draw a perpendicular line here. So the distance between these 2 points, okay, will give us our r. So we are going to integrate along the y direction. In this case, integration dy. The y value will be from 0 when x equals 2. The y value here is 4. R squared, keep in mind this r has to be a function of y. So if you look at here, this is x equals square root of y. So it will be 2 minus square root of y. Because this point A is square root of y, point B is x equals 2. So 2 minus square root of y give us the radius. Part B. If you look at here, same graph. However, we are revolving about x equals 3, this line. So when we revolve about this line, you see there will be a hole in the problem. There will be two radius here. First, we draw a line perpendicular to the rotating axis. So now we have 3 points, A, B, and C. Keep in mind, C is our center, which is on the rotating axis. Capital R will be AC. Lowercase r will be BC in this case. And we are still integrating along the y direction. Y is from 0 to 4. So we have capital R squared minus lowercase r squared. Capital R is AC, the distance between point C and point A, which is a function of y. So 3 minus square root of y. And BC, which is 3 minus 2. So point A, which is square root of y. Point B, which is 2. Point C, which is 3. So capital R squared minus lowercase r squared. Let's look at another problem. The region bounded by y equals 2x and y equals x squared. So let's have a look. So they intersect at 4, 2, 4. So this is also our rotating axis, x equals 4. So that's the region. So when we rotate about x equals 2, we know there's a hole in the problem. So we'll have capital R and lowercase r. We draw a line perpendicular to the rotating axis. 3 intersecting points, A, B, and our center, C. So capital R will be the distance between A and C. Lowercase r will be CB. Our integration will be dy along y direction from 0 to 4, capital R. So A, which is x equals y over 2. Point B, x equals square root of y. And C, x equals 2. So CA will be 2 minus y over 2, and CB will be 2 minus radical y. So after we find everything, we just need to plug it in. So this is rotating about x equals 2. If we rotate about x equals 0, which is the y-axis, there will be a hole in the problem. So pi integration 0 to 4 dy. However, the center now will be here, which will be square root of y minus 0 squared minus square root of lowercase r, which is dA here, which is y over 2 minus 0. If we rotate about y equals negative 2, we are going to do pi integration, which will be dx here. And the x will be from 0 to 2. So if we draw a line here, that's our center, A, B. So AC is our capital R, which is 2x minus negative 2 squared minus BC, which is x squared minus negative 2 squared